Hello everyone. In this video I'm going to be looking at how you can perform different tests to identify different cations. Now cations are positively charged ions, so I'll just make a little note just by the side. These are positively charged ions, and this is part of what's called qualitative analysis. We're not getting a quantitative value for it, we're looking to try and find and identify which cation we have maybe in amongst a particular sample. And the reason why this is important is because many of the metal cations actually in rivers and lakes, for example, can have very serious effects on actually aquatic organisms. So it's important in a sample to be able to identify what ions we have present. And I'm going to do two videos, one for cations, one for anions, which are the negatively charged ones. So this is part of a sequence of videos in inorganic chemistry where we're going to be looking at certain chemicals and their properties. So let's start this. I'm going to do it like a big flowchart by suggesting that we have our sample. So this is going to be our sample X. That's what we're going to start with. And we're going to follow a set path. We're going to first of all add to that sample some dilute sodium hydroxide. So the first thing we're going to do is add dilute sodium hydroxide. Now this is going to be quite a large sequence of events in here, so I'm going to be shrinking and enlarging the screen at various points. So we're going to add dilute sodium hydroxide, and then we need to consider if a precipitate is formed. So the question we need to ask ourselves here is, do we get a precipitate? Now, if the answer to that is yes, then we follow one path, and if it's no, we follow another. Now, if the answer is yes, then we need to consider the colour. So we'll put here the question, the colour. We want to know what colour that would be. Now, if the colour is blue, just a little shade in here. If the colour is blue, then what that means is we've identified copper 2+. That's the ion that we have, copper 2+. If the colour is green, then the ion that we've been able to identify in this case is iron Fe2+. And finally, if we have got a precipitate and that precipitate happens to have the colour of brown, so I'll just do a little shading patch here. If we get brown, then the ion or cation that we've found is again an iron but an Fe3+, with a 3+ charge on it. So if we add dilute sodium hydroxide to our unknown sample and we get a precipitate, if it's one of these three colours, we found those three. If the precipitate happens to be white, now here we're going to branch into a sort of another area. If we happen to have it white, we'll just draw a black box that's meant to be coloured white there, then that could be quite a few things. It could be either calcium, which is Ca2+, it could be magnesium, Mg2+. We could have the aluminium, which is Al3+. We could have also found Pb2+, which is lead, or it could be zinc, Zn2+. So we're going to need to do some further tests. Now, at the top where I said, do we get a precipitate? Yes, no. I will come back to the no bit. I'm just going to follow this yes side through first. So we've got a possibility, if we get a white precipitate, of either calcium, magnesium, aluminium, lead or zinc. So now what we need to do is add excess sodium hydroxide solution. So what we're going to do now is add excess NaOH solution. And then the question we have to ask ourselves then is, now does the precipitate dissolve? So does our precipitate dissolve? And the answer to this will then reveal which one of those ions we're essentially looking for. Now again, like I said, I'm going to need to shrink the screen here because this kind of flowchart is going to get quite big, so I'll just move this to the top there. I'll resize it as often as we need to, but I'll try and keep the screen nice and clear. So, does the precipitate dissolve is the question I've just asked. Now, if the answer is no, then we need to conduct a flame test. So if it's no, then we need to conduct flame tests, and these are often standard tests done in school. So we're going to conduct a flame test on the sample if a precipitate doesn't dissolve. Now, for that flame test, if we get 3 different colours, we can find 3 different ions. If that flame test happens to be red, so if it burns with a red flame, then what we found is calcium, Ca2+. If we happen to get a white flame, so if it glows with a white flame, then essentially what we found is Mg2+, magnesium. And if on a flame test it comes out green, then what we've identified is Ba2+, the barium cation. So that's if we've added excess NaOH solution and the precipitate does not dissolve, then we'll conduct a flame test and this is what we'll get. If that precipitate did dissolve, so if the answer to this part was yes, then that gives us a few other possibilities. It could be aluminium, it could be zinc, or it could be lead. So then what we're going to do is add a few drops of H2SO4, so sulfuric acid. So what we need to do at this point is now add a few drops of H2SO4, sulfuric acid. Now we need to look for if we form a white precipitate. So we're going to question whether or not we've got a white precipitate. We want to know if what we get is a white precipitate. Now, if we do, if the answer to that was yes, then what we've identified is something called Pb2+. We've identified the lead cation. If the answer is no, if we don't get a white precipitate forming, then what we need to do is add ammonia solution to some fresh solution in excess. So if it's no, then what we need to do is add ammonia solution to fresh solution. But the important thing there is that it's in excess. Then we're going to look for a white precipitate. So at that point, once again, we need to question, do we have a white precipitate? Now, the answer should be yes, we would do. If we add ammonia solution to fresh solution in excess, we should get a white precipitate at that particular point. But that's not what's going to help us identify the ion in this unknown sample. What we need to do is look at whether it dissolves on adding large excess. So if we keep adding lots of this ammonia solution in excess, if we keep adding lots of it, does this white precipitate dissolve? So white, I'm just going to add in brackets, white precipitate on adding excess. Now, if the answer to that is yes, then what we found is zinc, Zn2+. If the answer to that, however, is no, then what we've got is Al3+, aluminium, the aluminium cation. So I know the video looks a little strange, but we've looped around. So essentially what we've done is we've added NaOH, work out whether we get a precipitate. We're saying we are, and then we look at the colour to get copper, iron, or iron Fe2 plus or iron Fe3 plus. If it's white, then we've had to go through another process by adding excess sodium hydroxide solution. If it doesn't then dissolve, if the precipitate doesn't dissolve, we've conducted flame tests, and if it does, we've added H2SO4 and looks for a white precipitate. If not, we've added ammonia solution, and we find out if in excess a white precipitate that forms dissolves, and if yes or no, we get zinc or aluminium. And if we did have a white precipitate forming upon adding sulfuric acid, then we've identified lead. So we've identified a good number of cations here. Now what we need to do is come back to the very beginning where I said, if we add dilute NaOH, do we get a precipitate? And this time I'm going to follow the no path. Because before I had yes, and we've identified a whole range of different ions, but now we're going to look at no. So if we didn't form a precipitate, then we could get ones like sodium, potassium, NH4+. So now what we need to do is gently warm the liquid, and we're going to hold the indicator paper over the tube. So if to our sample X we've added dilute NaOH and we've not had a precipitate, then what we need to do is gently warm the liquid and then we're going to hold indicator paper over the tube. Now, then we need to look at whether that indicator paper turns blue. So that's the question we're going to ask. Does the paper that we're holding turn blue? Sorry, a bit of an unusual circle there. Don't know what happened there. Now, if the answer to that question is yes, if the paper does turn blue, then what we've identified is NH4+. If the answer, however, though, is no, if that indicator didn't turn blue, then we need to do a flame test. So once again, we're using flame test, but this time we're going to be able to identify two other things. If we do a flame test and that flame test happens to give a yellow result, I'll maybe make that a bit more obvious there, yellow result there. If it comes out yellow, then what we've identified is sodium Na+. If though, upon a flame test, we get a lilac colour, if it burns with a lilac colour, then what we've identified is K+, or the potassium cation. So there we have a whole range of investigations we conduct to be able to identify different cations, ions with a positive charge. So you start with sample X and you just follow this flowchart round. Upon adding dilute NaOH, if you look at whether we get a precipitate or not, yes or no, and you just follow this essentially through, and you'll be able to find out whether you've got copper or iron. You can see whether you've got calcium, magnesium, barium. You can see whether you've got zinc or aluminium. You can see whether you've got sodium or potassium. A whole range of ions here we can look for. And all we have to do is start at the top with our unknown sample and just follow this flowchart through. Okay, hope all that helps.